Today we're going to look at the three different forms of the quadratic equation that we can use to graph, and some of those forms have different advantages to the others as far as trying to find characteristics of those, and so it's important to take a look and see what those different forms are. And so the first one that we worked with was the vertex form, and this one had h and k. This was also the transformation form, so if we wanted to know how it was shifted from the original. And the vertex here is at h and k, and we know that that will also produce the value of the maximum or minimum of the function. So you can tell from A whether it's opened up or down, and that would tell you the max or the min. Remember that the vertex is also where it changes direction. So if you're looking at when the graph is decreasing versus increasing, it always changes at the vertex. So the vertex is a very powerful form. It gives us a lot of information, and because we can find a lot from that vertex. This was also, if we wanted to find the axis of symmetry, remember that just goes through h, so that's the vertical line through h. The other form that we worked with was the standard form, and a lot of times we were given equations in the standard form and then we would work with those. We can certainly graph from those. The one advantage of the standard form is that we can actually get the y-intercept from this form fairly easily because it is the value of c. So at the very end of this value right here is the value of the y-intercept. So that's an advantage to that. And the last form that we talked about was the factored form. And the factored form, if it is factorable, it will give us the exact roots of the quadratic, and those roots are a and b. Typically they need to be real numbers, and they're also the x-intercepts. So we know that it would cross at those two values on the graph. And then this does tell us the locations on the x-axis tell us where the function is positive and where it is negative. In other words, we can figure out the location. When does it start going below the graph, below the x-axis in the negative values for the range, and when does it have positive values for the range, because that's where it's going to cross. So we're going to take a look at a few examples from the notes on how to go in between all these forms, and then we can see the different aspects to them, and then we will use that to also graph the equations. So on our notes, you can see that we've been given a graph, and we are going to write equations in all three forms for this same graph. And so we'll just pick out some of the characteristics of the graph. Obviously you can see where it crosses the x-axis. We can find the vertex here pretty easily, and where it crosses the y-axis. So we could really start with any of these forms. The easiest one probably to start here is with the vertex form, because we can identify that the vertex is at -1, -9. So, and we also see that it opens up, so a is going to be positive. And we can see that if we write the vertex form, it's going to, h is -1, so we end up with x plus 1 squared, and k is -9, so we end up with -9. Now that's vertex form. To go from vertex form to standard form, all we're going to do is just simplify the quadratic, meaning that we're going to multiply it out. So we'll start with the vertex form, and remember that x plus 1 squared is really x plus 1 times x plus 1. So we'll separate out those binomials and then go ahead and multiply them out, which will give us x squared plus 2x plus 1. And then notice that the two constants are like terms, so we can add those together, and that's the standard form. Now in this standard form, notice that the constant is -8, and if you look over at the graph, in fact that is where it crosses the y-axis. And so again, the advantage of that form is that it's pretty apparent where that y-intercept is. So to go from standard form to factored form, all we have to do is to attempt to factor the standard form. And again, if if it is factorable, that just tells us that it does have at least one solution, and that solution is a rational number. So if we this one is clearly factorable if you look at the two factors x plus 4 and x minus 2, and then you can see over on the graph I've highlighted that it does cross at positive 2 and negative 4. So for the second example, we want to again we can identify the vertex if we wanted to start with that form as 7 and negative 1, and again it opens up in sort of the standard shape, and so if we write the vertex form, that goes actually very quickly because h is 7, k is negative 1, so we'll get our vertex form. So then to get standard form, we're going to take that standard form and multiply it out. And so when we multiply that out, notice that the middle term is negative and the last term is positive, and then when we take and add together the like terms, we get positive 48. So with that one, again, notice that from the graph you can't really tell that it's going to be you couldn't see that it's going to be positive 48, the y-intercept, but this part of the standard form certainly tells us that. And then this one happens to be factorable because 6 and 8 will give us 48 and add together to give us negative 14. So we're going to use minus 6 and minus 8 as the factors, which actually tell us that the x-intercepts are positive 6, 0, and positive 8, 0. And in the third example that we have, again, it's going to be good to identify the vertex first, and notice that it opens up, and it really sort of opens up at that same shape because if you go over 1 and up 1 from the vertex, that's where it travels. That's the standard width of a parabola. So writing the vertex, since it's shifted to the right 2 and down 9, it's going to be x minus 2 and squared minus 9. So you can see as the standard form, as we multiply that out, the standard form is going to give us a positive 4 minus 9 like terms, and we'll add those together, and that will give us the standard form. And notice that again, the minus 5 part of that standard form tells us the y-intercept because that's when x is equal to 0. And this one also happens to be factorable, so we know that it crosses at rational roots, meaning that they can make a fraction or they're whole numbers. And in this case, the two roots are positive 5 and negative 1, and you can see that it does in fact cross at negative 1, 0 and positive 5, 0. Now for the next examples, we've done a little bit something different, and that is we've been given the vertex form, and we're going to use that to create the graph. We could also we could transfer it into standard form and factored form, and we could also produce the graph that way as well. So if we look at the vertex form, the first thing we can tell is that the transformations have been to the left 5 and down 4. In other words, the vertex is going to be negative 5, negative 4, and then the leading coefficient is positive 1. There's a 1 in front of that parentheses, so that just means that it's the standard shape of the parabola and it opens up. We can we can't really see where the y-intercept is, so we'll find that out when we do the standard form. And the factored form, we can tell sort of where it crosses, where the roots are, so we'll confirm that when we do the factored form. But standard form, all we do is just multiply this out from the vertex form. And again, we're going to have x plus 5 squared, which is really just x plus 5 times x plus 5. And then when we multiply that out, again, notice that we've got like terms in the constants, and so we end up with a constant term of 21, which in fact is then our y-intercept. So it's going to cross at 0, 21. And we anticipated that this is factorable, and so again, factors of 21 are going to be 3 and 7, and so our factors are going to be x plus 3 and x plus 7, which we can see clearly on the graph as well, that we'd want to identify those. So again, the last two have a couple of variations in the shape, and so we'll want to talk about that. But if you want to try a few of these ahead of time, press pause, and you could do examples 5 and 6, and then press play to take a look at the results. So in example 5, the one thing we want to notice is that not only is the vertex going to be positive 1, 1, but the fact is that this is going to open down. And so it has the same shape that the standard parabola does, y equals x squared. And so you can graph that, except that it's going to open down. So one thing we have to consider is that negative that is out in front of the parentheses. Expand it first and go ahead and multiply the x minus 1 times x minus 1 first, and then we'll distribute the negative 1 through, or multiply the negative 1 through, which what will happen is it really just changes the signs of the trinomial inside the parenthesis. So you notice that it becomes, instead of negative 2x, positive 2. Instead of positive 1, it becomes negative 1. And then we still have like terms to do that, and so notice that the 1 minus 1 will give us that. So when we're factoring this, again, it's very helpful if you have the negative value to factor that out, even if you have to factor out a negative 1 as we did before. But notice that in this context, there's actually a greater common factor besides the negative 1, and that is the x value is common in both of them as well. And so again, this doesn't typically look like factored form, but if you do x minus 0 and x minus 2, that'll make it clear as to the two x-intercepts, or the two roots, are at 0 and positive 2. And then I just like to put, instead of maybe even the negative, you can emphasize the fact that the multiplier is negative 1 out in front. So in this last example, you can see that the multiplier out in front is positive 2, and so the vertex is going to be negative 4, negative 8, which is going to be down in the third quadrant. It's going to open up, but it's also going to have a stretch by 2, which means that when we go ahead and plot the vertex, that you're going to see that instead of going over 1 up 1 like we normally do, so from here over 1 up 1, we're going to actually double the distance here, and that's why we call it stretch. We stretch the distance by 2, so instead of over 2 up 4, we actually do up 8, and then same on the other side. So we can get our graph that looks like that. And so when we go ahead and multiply this out, again, let's do the exponent first. And so we'll multiply out the two binomials first, and then multiply by the 2. So we get the x plus 4 times x plus 4. We multiply that out to the trinomial, and then notice that we will multiply the 2, but the 2 only gets distributed to the trinomial, and so we get plus 32 minus 8 then, and then we'll combine like terms to get our standard form. And notice that again, this is going to cross the y-axis at positive 24. Can't really tell that from the graph, but the equation certainly does that for us. And then the factored form, again, if there's a leading coefficient, best thing to do is to look to see, does that actually factor out of everything? And in this case it does. Everything had a common value of 2, and so then we're just left with the trinomial that we can factor easily to x plus 2 and x plus 6, which does then correspond to the graph that this crosses at negative 2 and negative 6. So we have a lot of different forms that we can use, factored form, transformation, or vertex form, and then standard form. And the idea is that we want to be able to use the one that gives us the most information that we're looking for, and that's what some of our practice will be about today.